Hello guys, welcome back to the channel. Today we are discussing a special concept from riverboat problem. Here, the same concept is applicable to two cases. We'll deal with both the cases one by one. Let's talk about the left half here. Here we are dealing with a problem when shortest path in case of a man is swimming or a boat is traveling across a river. What is the shortest path? But now the condition is if man's speed with respect to river or man's speed in still water, that speed is less than river speed. Our original normal case says ki if the man wants to cross in shortest path, which is usually the straight line path, then man has to travel in such a way that man's velocity's horizontal component will exactly cancel river's velocity. So the vertical component can take him exactly across the river, right? But that can only be possible if man's speed is this way and this is reverse speed. That means the triangle that is formed, their man's speed is the hypotenuse. But what if the man's speed with respect to river is less than river speed? So in that case, this triangle cannot be formed, right? Because in a right angle triangle, the hypotenuse must be the largest side. But here man's speed is less than river speed. So this side is more and this side is lesser. That's why this triangle won't be possible. So what would happen in that case? So I'm taking man speed with respect to river as v and river speed as u, and we are analyzing. So for shortest path, here we know that man's speed's component won't be able to cancel river speed. So that means there must be some horizontal displacement. So how to know that shortest path? The path will be shortest if this horizontal displacement is minimum, because this vertical distance he has to cover anyway. If this horizontal part, let's say that is x, if x is minimum, then this total distance will be minimum. So that's what we are writing here. Here x cannot be 0, right? So for shortest path, x has to be minimum. This is reverse speed u. We have taken v this way and this angle as theta. So reverse speeds of man speed with respect to river, that one's horizontal component here comes to be this v sine theta. So net speed in horizontal direction, this is u and this direction is v sine theta. So they will get subtracted here. So the distance x will be equal to net horizontal speed into time, which is u minus v sine theta into time. Time we are taking from this direction. In this direction, the width is w and the velocity is v cos theta. So this gives us the time. The horizontal speed into time gives us velocity. So now we are rearranging the terms and we get this term. For x to be minimum, we see that this x is a function of theta here. So for x to be minimum, we take dx by the theta equals to 0, and finally our answer comes to be sine theta equals to v by u. Sine theta equals to v by u, where we have taken this as theta and this as v. So this forms a kind of triangle where this becomes a right angle triangle because this term is v and this side is u, right? So this angle, and we are saying sine theta, so this angle will be theta here. So this will form a right angle. Now let's see the right half case. The right half, the problem is in the right side, the minimum possible speed of man so that he can reach from A to B. This is a point which is given as A. This is another point B. They have given us these 2 points and they are not exactly across as shown in the diagram. So a man has to move from A to B in shortest possible speed, minimum possible speed. So here what we are doing is we are assuming a random direction because the man has to actually move in this way. So he will try to swim in certain direction and the river will also carry him. So the net speed should be along AB. This AB will be net speed, means man's speed plus river speed. The summation should be in the direction of AB, right? We are taking, let's say, V, man's speed with respect to water at some angle alpha. So in that case, the horizontal displacement we write as V cos alpha plus U and vertical displacement as V sin alpha into T. Here V cos alpha plus U into T. Now this T we are equating from both sides. From the upper equation T is x by this much V cos alpha plus U, and from the lower equation it is y by V sin alpha. If we equate them and solve, we get v as this function. Here, if v has to be minimum, then this term has to be maximum, right? X sine alpha minus u y cos alpha. This term has to be maximum. That means v term we are getting as u into y by x square plus y square root over, because this term will be maximum and this maximum value will be x square plus y square root over, right? And that will happen when tan alpha equals to minus x by y. We can differentiate this function and check. So tan alpha equals to minus x by y gives us v minimum condition, but this negative value shows that this alpha cannot be acute, it must be obtuse angle, and hence this v is not here. Basically the v direction must be some certain direction like this. Now what do we conclude from these two cases? Let's see one diagram here. If this speed is v and this total speed is u, we see that if we take this angle alpha theta, then and this has 90 degree, then this angle will also be theta, right? Because if this is theta, this will be 90 minus theta, so this will angle will also be theta. So from here we get sine theta, this sine theta value as perpendicular by hypotenuse, which is v by u, which happened in our first case. See here, sine theta equals to v by u. And if we see to this triangle, look at this triangle here. If this angle is theta, then sine theta should be this side by this side, right? But what is this side? This is y. And what is this side? This side is, let's say this is x, so this will be y square plus x square root over. Now see the our right half analysis here. Here we got that v minimum. The v equation we are getting as uy by y square plus x square root over. Look at this term. This term y by y square plus x square root over. This itself is that sine theta, right? And this comes to be v by u. See, v by u. So that means in both of the cases, if a man wants to cross the river in a certain possible direction which is not exactly across, let's say it is moving from this point A to this point B, and he has to move in minimum possible speed. He has many ways to reach B at different speeds, but what should be the minimum possible speed? This is one case. The other case is, what should be the shortest path of the man if his speed is less than river speed? Man's swimming speed is less than river speed, then he cannot move exactly across, right? So what will be the actual path taken by the man? In these both of these cases, we see the man's swimming speed is in certain direction that he's trying, he this is the direction he's trying to move, right? His speed with respect to river, and this is the direction in which man is actually moving. These two will always be perpendicular, and this hypotenuse direction will give us the river speed. So we can use this short trick to solve many problems. Here I'll give one problem. You guys try and comment the answer in the comment section. See, this is the question. Read it and answer it in comment section. I'll reply if it is correct or not.